Welcome to the wonderful world of programming using Java. This presentation introduces your first programming project in the class, the Paycheck program. Watch this video carefully. It not only covers the first project, but many of the small details in the Java programming language. You may want to watch this video more than one time, especially if this is your first class in programming. You not only need to complete the project, but you also need to understand the information presented because it forms the basis for all of the rest of the class. As the course progresses, you will be required to start a project from scratch and create the entire project yourself. I will cover the Paycheck lab assignment by discussing the project definition, how to develop an algorithm, entering and running the program, and completing and submitting the lab report. With Java, it really does not matter whether you're using a Mac, a PC, or Linux. Before you even start, I suggest that you create several folders on your computer or storage device. Main folder for the Java programming class. One subfolder to keep copies of all your lab reports, separate subfolder for each lab project. You may want another folder to keep copies of the class presentations. The college removes the class Canvas web pages after the end of the class. Here is the project definition. Create a program using Java that does the following. Read the number of hours worked and pay rate. Compute the pay, including overtime, at time and a half. Change the withholding tax rate from 17% to 21%. Compute the taxes. Display gross pay, taxes, and net pay. Even if you are really smart, really smart, and know how to pay no income tax at all, the tax withheld for this project must be 21%. The first thing to do when given a programming task is to figure out what the output should look like. Draw it out on paper. As the project progresses, don't worry if the actual program output doesn't look exactly like your original plan. Plans can change. Pseudocode is fake code. It's code that's really not any language. It's more like English. A lot of times pseudocode is given to the programmer to say, here is how I want the program to work, and it's up to the programmer to write the code in Java, C, C++, or whatever language is being used. In this hierarchy input process output chart, also called a hypochart, we want to define the inputs. In this case, it's the hours and pay rate, and the outputs, gross pay, taxes, and net pay. First, identify the inputs and outputs. Once we know these, we then need to decide how to get from the input all the way to the output. We're going to read the hours and pay rate from the keyboard. Determine the number of regular hours, determine the number of overtime hours, compute the regular pay, compute the overtime pay, and then compute the gross pay. Compute the taxes, and finally the net pay. That's what's left over after everything has been taken out. Finally, display the gross pay, taxes, and net pay. I am going to use flowcharts to continuously break down the program into smaller, manageable parts. Flowcharts are used to represent different steps of a program. The most commonly used symbols are those in the left column. A circle or round rectangle is used to indicate the beginning or end. The parallelogram is used for input or output. The rectangle represents some type of process, and the diamond is used to represent a decision. Other symbols can be used to represent subroutines, functions, disks, databases, etc. Although flowcharts are not used as often as they once were, they still help give a visual representation of how a program is organized. The concept of structured programming states that all programs can be created with only three constructs: sequence, selection, and repetition, or a combination of any of them. Sequence is the easiest to understand. Program steps are executed sequentially, one after another. Many times, the order in which the steps are executed is very important. Other times, it does not really matter. For example, if I were baking a cake, it may not matter very much whether I put the egg in the bowl and then the flour, Or I reverse the two before mixing them with water. However, it would make a lot of difference if I put the cake batter in a 9 by 13 baking dish, placed it in an oven for an hour and 30 minutes, took it out, and then turned the oven on to 350 degrees. Yuck. This simplified flowchart shows the sequence of steps that are required for the program. There are no loops, so the repetition structure is not needed. In another slide, I'm going to expand the Compute Paycheck box to show a lot more detail. Here are two examples showing the hours worked with an example of $20 per hour. The first example shows 37 hours, which is less than 40, therefore there's no overtime. All 37 hours should be paid at $20 per hour. The second example shows 45 hours. Therefore, the first 40 hours should be paid at the standard rate of $20 per hour, but the overtime of 5 hours should be paid at time and a half. That makes the overtime hours paid at $30 per hour. The easiest way for the program to compute the pay is to separate the hours into regular hours and overtime hours, and then compute the pay separately for each. I've expanded the flowchart to show more detail in computing the paycheck. The center column uses a diamond to represent a decision. The program needs to look at all of the hours worked to see if they are less or equal to 40. In this case, regular hours are set to the number of hours worked, and the overtime hours are set to 0. However, if the test condition of hours are less than or equal to 40 is not true, there is some overtime. Therefore, we set the regular hours to 40 and set the overtime hours to anything over 40. If hours is 43, then the person worked 40 hours at regular pay and had 3 hours of overtime. Overtime hours equals hours minus 40, which is 3. We can then proceed to compute the gross pay, payroll taxes, and net pay, and then display them. We need to remember that payroll tax is computed on the money that you make, and sales tax is collected on the money you spend. In this project, we are working with the payroll tax. Program organization. Most of the programs you will write will be organized like this. Use comments to place a title block at the top of each file. The title block identifies what this part of the program does, as well as the date, version, and programmer's name. It can be very frustrating later on when there are many files that make up one program and you look at a file that contains code and have no idea what the code does. You then need to reanalyze or reverse engineer the code instead of just looking at a short description in the title block. Many companies want the programmers to place their name in the file in case anybody has questions about the file. The date and version number also help identify the latest version of the program. The first part of the real code contains the import statement and any global variables and constants. Next is the main body of the program with its 4 subsections: list of variables, input, process, output. Next, convert the algorithm into code. The real work gets done during the input, processing, and output sections. Most of what is in the first and last sections is really just housekeeping to get the program started and shut down. If you're using a Mac or a PC, you should have already installed Eclipse or NetBeans on your computer. If you don't have Eclipse or NetBeans yet, you can use JDoodle for this project with just a web browser. You will need to install Java and preferably a full-featured IDE on a computer for future projects. Using Eclipse, you need to specify a workspace folder for the first time you start Eclipse to identify where your projects will be stored. The Eclipse window is divided into several sections which contain several views. One can be the text editor, another one a list of your projects, the console output, etc. These are all combined into the Java perspective. As you become more experienced, you may want to use the debug perspective. To use the Eclipse IDE, create a Java project, new, file, Java project. Your code should be in a directory named src for source. Create a new Java class. Right-click the Java project name in Project Explorer, new class. Don't add .java to the end of the class name. Syntax errors will be underlined with a jagged red line. The light bulb gives suggested fixes to errors. Control space will help complete your typing. Click Run to start your program. Be sure to click the mouse in the console window before typing entries for things like hours or pay rate. Using NetBeans is very similar to using Eclipse. Even the layout of its window is very similar to the Eclipse window. To use NetBeans, create a Java project, new project, Java application. Enter name for your project instead of the default name. Create a new Java class. Right-click the Java project name in Project Explorer, new class. Again, don't add .java to the end of the class name. Syntax errors will be underlined with a jagged red line, and the light bulb will get suggested fixes to errors, etc. Control space will help complete your typing. Click Run to start your program. And again, be sure to click the mouse in the console window before typing entries for things like hours or pay rate. All you need to use JDoodle is access to the internet and a web browser. It is a free online compiler that works for many languages, including Java. You can use JDoodle for the first few lab assignments, but you need to install Java on a computer system such as a Mac, PC, or Linux for many of the projects in the class. You will not be able to use JDoodle for graphic user interface projects. JDoodle may also not work with multi-file projects or programs that access files on the disk. To use JDoodle, start JDoodle at https://www.jdoodle.com/online-java-compiler. Enter your program. Note, you do not need the line at the top of the program that identifies a Java package. Remove it. That's package. Paycheck. Be sure to save your work on a regular basis. To copy your program into the clipboard on a PC, use Control-A, Control-C. On a Mac, use Command-A, Command-C. Set the interactive mode to on and click Execute. Using Java in a console mode is really cool if you are a real computer geek or a computer nerd. If you're not sure how to locate the JDK in your computer, or even what it is, or how to modify the operating system path environment variable, I strongly suggest that you do not use the command mode for now. To use the command line interface, make sure that the JDK is installed and the path environment variable includes the folder of the JDK. Use a text editor such as Notepad or TextEdit to enter your program and save it in a file whose name is the same as the class name of the Java program. Example, Paycheck.java. Use Java-C to compile a program. If there are any errors, fix them with the editor and recompile the program. Java-C, Paycheck.java. Use the Java Runtime Executive, JRE, to run the program. Java, Paycheck. Note, do not include the .java extension. And here is a sample run of the program starting with the Java compiler. Java-C, Paycheck.java. Start the compiler with the Java-C command, followed by a list of files to be compiled, complete with their .java file extension. Once the compiler shows no errors, use the Java command to actually run the program. Note, don't include the .java file extension here. The characters in blue represent what the user needs to type in response to the prompt messages. Congratulate yourself when you have a successful run of the program. Enter the program. Get a copy of the code from the class website and print it. The code is provided as an image file. You need to type the program yourself to complete the lab project. You will learn far more by entering the program yourself than if you have someone else enter it or use a scanner to convert the image of the program code into actual Java code. Be very careful when typing Java programs. Except for comments, Java is case sensitive, which means that the uppercase letters, capital A through capital Z, are treated completely different from lowercase letters, small a to small z. Do not put spaces in the middle of variable names. Example, overtime pay has no spaces. Watch the placement of the semicolon character. It does not appear at the end of every line. Use \n to move the cursor to the next line when outputting text. The \n uses backslash, not the /. Pay close attention to the parentheses, the curly braces, and the angle brackets. The title block at the top of the program file uses the block style comments starting with the /* and ending with a */. The comment block identifies what is in the file as well as the inputs and outputs. Some companies want the programmer's name in the title block. Others don't. I want your name in the title block, and I will look for it when I grade your projects. Although not shown here, another couple of things that are actually placed in the title block are the version number and the date. This can help determine the latest version of the code when there are multiple files that are not the same. The line package paycheck is not needed when using either JDoodle online compiler or the command line compiler. The import java.util.scanner brings in the code for the program to read from the keyboard if using the scanner object. Java is an object-oriented programming language. Objects are defined with a class statement. Each Java class must be in its own file, and the name of the file needs to be the same as the class with the Java extension. The Paycheck program is defined with public class Paycheck code and must be in the file named paycheck.java. The curly braces, open curly brace, close curly brace, are used to identify the start and end of a block of code or data. Many other programming languages use the words begin and end instead of curly braces. Each open curly brace needs to have a matching closed curly brace. The closed curly brace for the public class Paycheck is at the end of the file. This means that everything else in the file belongs to public class Paycheck. Java does not have the exact same thing as a constant definition like C++ or Visual Basic, but the same thing can be accomplished using public static final to define the equivalent of a constant. For normal identifiers like variables, subroutines, methods, and object, it is traditional to use the camel case method for the names with the first word in each name capitalized. Class definitions typically have the first letter capitalized, but variables, subroutines, and methods use the first letter in lowercase. To make constants easier to identify, they are usually done with all capital letters and use the underscore character to separate words instead of spaces. Constants are used later in the program so that the values will have a name instead of just a number. For example, when tax rate is used in the expression taxes equal gross pay times tax rate, it is much better than taxes equal gross pay times 0.17, because someone looking at the program may wonder where the 0.17 came from and why it is there. If 0.17 were used, it would be referred to as a magic number. Who knows how it got there? Another reason to define tax rate at the top of the program is that it may end up being used more than once in a larger program. Changing it where it's defined makes sure that it gets changed everywhere. A comment is provided for both overtime rate and tax rate so that the next person reading the program will know what the numbers actually mean. The program itself is enclosed within the curly braces, starting by the line public static void main, open curly brace. The character that follows the closing parentheses is the open curly brace. There needs to be a closed curly brace near the end of the file. Constants and variables must be declared before they can be used. I placed the constants and variables at the top of the program and even declared several variables on the same line with a comma between each variable name. Depending on where you work, some companies permit closely related variables to be defined on the same line, while others require that each variable be defined on its own line. A comment should follow any variable definition that is not perfectly clear from its name. When writing a console application, it is necessary to output a prompt to the screen to request data from the program's user. If you don't have a prompt message, all the user will see is a flashing cursor and probably think the program crashed. You need to think of yourself as two different persons when writing a program that has a user interface. As the program developer, you need to have the program display a prompt message asking the user to input a number for hours. As the user, when you see the prompt message, you will know it's your turn to type the number of hours. Don't have the program display 40 and then just sit there waiting for something to be typed. When writing a prompt message, I like to end the prompt with a colon and a space to let the users know that they need to type something in. The space after the colon is to make the screen look nice so that the user's typing won't be right next to the prompt. It is necessary to create a scanner object in order to use the scanner to input data from the keyboard. You can give the scanner object any name you wish, but make it descriptive. In the past, I've used scanner input and scanner keyboard. Whatever name you use as the definition, this is the name that you need to use later in the program when reading from the keyboard. David Eck, the author of the textbook, has provided the Text.io user interface that makes the program much more user-friendly. When using Text.io in your program, it checks to see if the characters typed as user input are appropriate for the data type in the program. It has the program retry the user's input if the information typed does not look good. On the other hand, programs using Scanner for keyboard input will crash and die if the characters typed are not appropriate for the expected data type. For the Paycheck program, I want you to use Scanner, especially for the next lab. You will be identifying different types of errors that can occur with a computer program. The if-else statements are used to identify the number of regular hours worked and the number of overtime hours. The if statement has a logical expression enclosed within the parentheses that is testing to see if the hours are less than or equal to 40. The logical expression must evaluate to either a true or false. When the expression evaluates true, that means there's no overtime and the block of code attached to the if statement is executed. When the expression evaluates false, the block of code attached to the if statement is skipped over and the code attached to the else statement is executed. The curly braces identify the begin and end of each block of code. If there is no overtime, just set the regular hours to the number of hours worked and the overtime to 0. If there is overtime, the first 40 hours get paid at the regular rate, but anything over 40 gets paid at time and a half. Set the regular hours to 40 and the overtime hours to anything over 40. The computations for reg pay and overtime pay are fairly straightforward. Reg pay equals reg hours times pay rate. Overtime pay equals overtime hours times pay rate times overtime rate. The overtime rate is from the constant 1.5 at the top of the program. The gross pay, paid before taxes or any other deductions, is the sum of reg pay and overtime pay. Taxes are based on the tax rate defined at the top of the program. Net pay is anything that's left over from the gross pay after the taxes have been deducted. The first part of the format string in printf is just text that will be displayed. Your pay is $, followed by the format specifier %.2f, and then \n, which moves the cursor down to the next line. The %.2f tells printf to replace the %.2f with the data that is in the next printf parameter. The f identifies that the data is expected to be of type double, and the .2 says display 2 digits past the decimal. If pay were computed at $803, then the output on the screen would show your pay is $803.00, and the \n moves the cursor down one line. Remember how printf displays 2 digits past the decimal. You will need this in future lab assignments. We open the scanner object near the top of the program as one of our resources, and we should close it when we're done with it. We will need to do something similar in later programs when we open a disk file. The first closed curly brace matches the open curly brace for the main, and the second curly brace matches the open curly brace for the Paycheck class definition. Many of the IDE systems will let you double-click on an open or close parentheses or curly brace. It will turn yellow, and so will its mate. This helps make it easier to find the matching pairs. What is this program missing? This may seem like a big task for your first program, but a lot of code is missing to make a robust program that is more user-friendly and able to detect and handle bad inputs. Here are some things that are missing that we will need to learn how to process in later projects. Check for negative hours, pay rate, or taxes. Check for hours greater than 168. That's the maximum number of hours in 1 week. Check for excessive pay rate or tax rate. Check for illegal inputs. Since this program can process a paycheck that does not have overtime, 40 hours or less, and also a paycheck that has overtime, more than 40 hours, it is important to test both conditions. It is also important to test the program at 40 hours to make sure the program did not check for only greater than and less than and skip testing for 40. Project documentation and lab report. A multi-page text document for the lab report is provided. Most of the lab report for this project is already filled in. You need to complete the rest of the lab report. You need to complete the test values and results table. I've already provided some sample test values. If you use any values other than 39, 40, and 41 hours, or a pay rate other than $21 per hour, you need to update this table. Use a calculator to compute the expected results and then put what was computed by your program in the actual results column. Don't just copy the program output into the expected results. Otherwise, how are you going to know if the program is actually producing the correct results? When you submit your lab assignment, I may be comparing the data in this table to the 3 screenshots that are also part of the lab report. In the discussion section of the lab report, you need to write what you did to develop the program, any problems you had, and how you overcame those problems. I don't expect a lot of writing, but I want you to describe what you did for the project. I realize that not everyone taking this class may have perfect English. Try your best. I may mark up your report for English composition problems to help you in your writing, but I will not take off any points for your English. This is a programming class, not English 1A. The lab has instructions on how to copy a small portion of the screen. If you place a screenshot of the entire screen, I may not be able to read the output of your program. If this happens, I may ask that you resubmit your report. Congratulations on completing your first Java assignment. Refer back to this lab assignment when working on future labs for instructions on creating new Java programs. And a special thanks to David Eck for sharing his textbook, Introduction to Programming Using Java. Bye-bye and enjoy this lab. Have fun. I hope you learn a lot.